All right, so this is 1510 here, and we have a 50 kilogram crate, and there's a force on it, P here at 30 degrees. We're given that the coefficient of kinetic friction is 0.2 between the crate and the ground, and we know it achieves a speed of 10 meters per second after 5 seconds here. So we're supposed to determine the magnitude of P. All right, so let's start the analysis. So we're going to use impulse momentum equations here. So let's draw a free body diagram of the crate right off the bat here. So we have the crate, and then we have P, which is 30 degrees up here. We're going to have a normal force, and then we're going to have friction force on the bottom, which is 0.2 times the normal force, and we have the weight as well downward. Okay, so let's do the y direction first. We'll break this down into the equations in the x and the y direction. So let's do the y direction first. So we have m1 v1 plus the integration from t1 to t2 f dt equals m1 v2. Okay. All right. So we know it starts from rest. So the velocity at 1 is 0. So we have that. And now we just need, and all the forces are constant. So this integral is just going to come out to be the forces times the 5 seconds. So all of the forces in the y direction, so if we have our coordinate system x, y, the positive here will be p sine of 30 degrees. P sine 30 degrees. And remember, the sine of 30 degrees is 0.5. And then we have plus n. And then minus the weight, and the weight is 50 kilograms times 9.81. And all of that times the 5, and that is equal to the mass times the velocity at 2, but we're just talking the y direction here, and there's 0 velocity in the y direction, so this side is also 0. And for solving for that, we can get the equation for the normal force, which is 490.5 newtons minus 1/2 p. Okay, so that's the normal force, and we're going to need that in the x direction when we do the x direction equation. So let's go to the x direction. Okay, and we're going to write out the same equation, but just remember this is the x direction this time. F dt equals m1. We really only have one mass times the velocity 2. Okay. All right, it's still starting from rest, so this comes out to be 0. And all the forces are constant still, so this integration here is nothing more than the force times the amount of time that this force is acting, which is 5 seconds. So going back up to our free body diagram, in the x direction we have the p component, which should be p cosine 30. So p cosine 30 degrees. And what other forces do we have in the x direction? This 0.2 as well, this 0.2 times the normal. And that's acting in the negative direction. And we know the normal here is 490.5 minus 0.5 p. And don't forget to multiply this by, these are the forces here, we need to multiply those times the time, 5 seconds, to complete this term here. and that is going to be equal to our mass times our velocity at 2. Our mass is 50 kilograms, and our velocity, which is given in the problem after 5 seconds, it is moving at 10 meters per second. So solving this equation, we have P comes out to be 205 newtons, and the normal force, if we care about it, comes out to be about 388 newtons. All right, so that is the answer to 1510.